Morning, everyone. In continuation to our series of sessions on basic course in biomedical research, I welcome you all to the 11th session on sampling methods. I am Dr. Amrit Virk, Professor and Head, Community Medicine at the B.R. Ambedkar State Institute of Medical Sciences, AIIMS, Mohali. The learning objectives of today's session would be to understand the terms sample and sampling, to understand the need for taking a sample, to understand different types and methods of sampling, its advantages, disadvantages, uses, and examples, and to understand the basic types of sampling errors. Let's start with what is sampling. Now, sampling has been defined in a variety of ways. It is basically a scientific and an objective technique of selecting a representative part of a population for the purpose of determining parameters or characteristics of the whole population. Sampling actually provides the means of making inferences about the population of interest using observations that are made on the sample. The method of selecting a sample of individuals who become research participants is extremely critical because sampling allows one to obtain a representative picture about the population without studying the entire population. And it is a very important component of any piece of research because of its three main properties. And these properties being that firstly, sampling allows for a greater accuracy to the research. Then it allows for less time to collect data, and also that sampling makes a study less expensive. So before we move on to define certain key terms, these key terms being the population, the target population, sampling frame, the sampling unit, and the sample. So what exactly is the population? Population is defined as the entire group under study, and sometimes this is also referred to as the universe. At the broadest level of the population, we have a group of individuals possessing one characteristic that distinguishes them from the other groups. At a more specific level, researchers do not always study an entire population. Now, this can be either because they cannot identify the individuals or because they cannot obtain the lists of names. Now, in practical operational terms, researchers study a target population, which is also sometimes referred to as a sampling frame. This is the list or the record of individuals in a population that a researcher can actually get access to. At the most specific level, researchers select a sample from the target population. These individuals are the people studied and from whom generalizations are made about the entire population. Let's look at what are the characteristics of a good sample. A good sample should be true representative of the population because the inference drawn, it refers only to the defined population. If the sample size is adequate or if it is appropriate, it affords a lot of precision to the study. Ideally, sampling should be unbiased in character, but please remember that whatever way or whatever technique we may employ in selecting a sample, some difference will always persist, and this is what is attributed to sampling error. The next term that we need to define is a sampling unit. Sampling unit is the smallest element of the population from which a sample will be selected. Now, this sampling unit can be a household, a family, or an individual with a specific characteristic within the sample. A sampling unit is generally well-defined and identifiable. For example, to select persons, a sampling unit becomes an individual person. And to select families, the sampling unit becomes a family. We also need to know what is a sampling frame. A sampling frame is a list of all the sampling units from which the sample is drawn. So if in the broadest sense you have the population from which we take out a sampling frame, and from the sampling frame we draw a sample. Example of a sampling frame could be a telephone directory or a listed student from your college. So now that we've defined the terms, let's now try to understand what is a theoretical population, what is a study population, what is a sampling frame, and what is a sample. Theoretical population is the population to which we want to generalize our findings to. The study population is the population that, as a researcher, we can get access to. The sampling frame is how we can get access to the study population. And who are in the study? That becomes our sample. So this is how we do the sampling breakdown. The main purpose of sampling in any research is to help the researchers to be able to collect data by making use of the limited available resources. And these resources could be in terms of money, material, manpower, and time. And also, another main purpose of sampling is that it helps us to draw inferences that we can generalize to the population. Broadly, sampling schemes or sampling techniques or sampling methods are of two types. We can have probability sampling and non-probability sampling. What exactly is a probability sampling? Probability sampling is a technique in which every unit in the population has a chance greater than 0 of being selected in the sample. And this probability can be accurately determined. In other words, it can help us to draw valid conclusions. While in case of non-probability sampling, the probability of selection cannot be determined. Under the probability sampling techniques, we have simple random sampling, systematic sampling, stratified sampling, cluster sampling, multi-stage and multi-phase sampling, and among the non-probability sampling techniques, we have convenience sampling, judgmental sampling, purposive sampling, quota, and snowball sampling. Now let's try to understand the difference between probability and non-probability sampling. In case of probability sampling, it is essential to have a list of the population elements, which is not so in case of non-probability sampling. For probability sampling, some sampling skill is required. Again, this is not so for non-probability sampling. Probability sampling is time-consuming, and the cost per unit sampled can be moderate to high, while in case of non-probability sampling, the time consumption is quite less, and also the cost per unit sampled is quite low. The estimates of population parameters are unbiased in case of probability sampling, which is not so in case of non-probability sampling, and sample representativeness is quite good and quite assured in case of probability sampling, which is undeterminable in case of non-probability sampling. Also, when we talk about accuracy and reliability, this can be computed with confidence in case of probability sampling. However, it is unknown in case of non-probability sampling. So these were just a few of the differences that we need to know regarding probability and non-probability sampling. Now let's look at the various sampling techniques and probability sampling. The first and commonest, or rather I would say the most basic and even the easiest method is simple random sampling. And simple random sampling, it applies the principle of laws of chance, wherein all the subsets of the sampling frame, they have an equal probability, and accordingly, each element of the frame has an equal probability of getting selected in the sample. Now, this sampling technique, it is applicable particularly when the population is quite small, it is homogeneous, and it is easily accessible. And simple random sampling consists of 6 basic steps. These steps include defining the population, choosing the sample size, listing the population, numbering the units, randomization, and selection of the sample. Now, among all these steps, it is the step of randomization which is very critical in this particular sampling design. And this step of randomization can be done using either the balloting or lottery method, by using random number tables, or even by using a computer program that can generate these random numbers for us. In the lottery method, we have 2 types of lottery methods. And these can be lottery methods with replacement, wherein the possibility of being selected twice or more is there. And there can be lottery method without replacement, in which case we do not replace what has already been taken out, and it is more convenient and provides a more precise sample. The other method, let's take an example of the lottery method. Supposing we have to take out 30 patients to be put in a certain trial out of an available of 300 available patients. Now here what we can do is we can note the serial numbers between 1 to 300 because that is the total number of available patients on a card, and we can shuffle. So we can draw out one and we note the number, and that would be the number of the patient that we include in a sample. We can reshuffle the pack of cards and draw the second card. We can use both the methods over here, whether by replacement or without replacement. And this process is repeated till 30 numbers are drawn. And these 30 numbers would be the 30 patients that we include in our sample. The other method of randomization is a random number table. This is a randomly generated number table which provides random numbers, and especially these random numbers have been designed for sampling purposes. And these random number tables can be found at the end of the statistical textbooks, and they can be made use of. For example, this is one picture of a random number table that can be made use of. If we look at the advantages of simple random sampling, we need to remember that the biggest advantage of SRS method is that the sample is representative of the population, and every element gets an equal and independent chance of selection into the sample. However, this method is again not devoid of disadvantages. The major disadvantage being that this particular method is a little impractical or not feasible in case of very large populations, because it requires a lot of resources, and also a complete list of units is actually needed. So these things need to be kept in mind, that even though simple random sampling is a very scientific method, but practical problems may be there of difficulty. It is quite impossible to make a complete list of all the subjects in a population from which the sample needs to be selected. The second type of probability sampling technique that we will talk of today is the systematic random sampling technique. A systematic random sampling technique is also simple and quite convenient to adopt. And here, basically in this method, this sample is drawn by selecting the first unit by simple random sampling, and then additional units are taken at evenly placed intervals. To find the additional units, we need to calculate something which is called as the sampling interval or the sampling fraction. So these are the steps for systematic random sampling, wherein we first calculate the sampling interval or the sampling fraction, which is denoted by the letter K. And this letter, the sampling interval, it can be obtained by dividing the total population by the sample size. So for example, let's take an example that we want to select a systematic random sample of, say, 1,000 students to evaluate the prevalence of hypertension among 10,000 students in a given university. So if we have a total population of 10,000 and we need to take out a sample size of 1,000, our sampling interval of K, it becomes 10. So once we know the sampling interval, then we can randomly select a number from 1 to 10. And this can be any number. Say, for instance, if we have picked up a number 6, okay, then the first sampling unit would be the 6th student. And then thereafter, we keep on adding 10, which is a sampling interval. And then after 6th, we will pick up 16th, and then we will pick up 26th, and so on till our sample size is obtained. So here again, in this particular example, we can see that every member is selected from a list of all the population members. So in this particular example, every 20th person has been picked up after picking the first person at number 8. Then thereafter we are adding 20 to 8. So we get the 28th person, and then we add another 20 to 28, and we get the 48th person. So that is how we go about the systematic random sampling method. Looking at the advantages of the systematic random sampling method, it is a simple method which is quite cost effective. And here the sample is easy to select and it is evenly spread throughout the population. The sample is evenly spread over the entire population. So looking at the disadvantages, here one particular thing that we need to keep in mind is that this method is difficult if our population is heterogeneous. So we need to keep this limitation in mind if at all we are thinking of picking up systematic random sampling as a method. The other important disadvantage of systematic random sampling method is that the sample may be biased if at all there is hidden periodicity in the population, because that may coincide with that of the selection. So this is one of the disadvantages, another disadvantages that we need to keep in mind. Coming to the next method of probability sampling is stratified random sampling. This technique, it is employed when the population under study is non-homogeneous. So what we do over here is that the population is first divided in strata depending upon the characteristic of interest. Now, this characteristic of interest can be a variety of things. It can be the gender, so you can divide them into stratas of women and men, or you can even divide them into stratas such as socioeconomic groups. Okay, so let's take an example over here. For example, we want to find out the alcohol consumption in a population. We would like to do a stratified random sampling. We can stratify by age. So here, stratification at 10-year intervals, such as picking up one strata could be people 20 to 30 years old. The next strata would be 30 to 40 years old, and the next would be 40 to 50 years old. So that is how stratification by age can be done. Now we look at the advantages of this particular method. Here again, the biggest advantage is that every unit in the strata it has an equal chance. So there is adequate representation of the minority subgroups. However, we can have some demerits also for this, that the sampling frame of the entire population needs to be prepared for each of the strata. For each of the minority subgroups, you need to have a sampling frame in hand before you go in for this particular method. The next method of sampling under the probability sampling techniques is the cluster sampling method. This is a technique in which clusters of participants which represent the population are identified and then they are included in the sample. So what we do is that the population is divided into clusters of homogeneous units, and these homogeneous units are based mostly on geographical contiguity, wherein sampling units are groups rather than individuals. And this method can be used to cover large spread area. And the major reason for cluster sampling, why it is most commonly, wherever it is employed, is the cost efficiency advantage of this particular method. Now, under cluster sampling, we have two types of cluster sampling methods, the one-stage sampling method and two-stage sampling method. In the one-stage sampling method, all of the elements within selected clusters are included in the sample. As we can see in the diagram over here, we can have the population out of which we choose 3 clusters, 1, 2, and 3, and all the elements within these clusters are picked up in the sample. The two-stage sampling method is the one wherein a subset of elements within the selected 1, 2, and 3 clusters, these are randomly selected for inclusion in the sample. So that becomes a two-stage cluster sampling technique. Now for cluster sampling, it is important that for identification of the clusters, we need to have a list of all the cities, towns, villages, and wards of cities with their population falling in the target area under study. Again, for cluster sampling, we need to calculate the cumulative population and we divide it by the number of clusters. And this would give us a sampling interval. So first, we are going to select a random number which is less than or equal to the sampling interval having same number of digits. And this would form the first cluster. Then the random number cluster plus the sampling interval, that would give us the population of the second cluster. And second cluster plus sampling interval would give us the population of the third cluster and so on. So this is how cluster sampling is done. Looking at the advantages, we see that one of the bigger advantages of cluster sampling technique is that it is economical and a large sample can be obtained for a similar fixed cost. and less time is needed for listing and also for implementation, and that is how it saves us time and even the cost of traveling. The disadvantage, however, of this technique is that sampling error is higher as compared to other sampling designs of the same sample size. So again, this is something that we need to keep in mind with cluster sampling. The other technique of sampling under the probability method is the multi-stage sampling. It is particularly used when the sample is to be drawn from a huge population, like a country or a state. But one important part of the multi-stage sampling is the flexibility part, which is in fact a key feature of this sampling technique. And this sampling technique, it is commonly used in large-scale surveys. So when we talk about flexibility, what we mean to say is that different types of sampling methods may be used at different stages. So let's look at this example. For example, if we want to carry out a survey to know the vitamin B12 deficiency in Bhubaneswar, so from the city, then we identify, in the first stage, we can identify the zone, and we can use, say, the simple random sampling technique using lottery method for that. In a given zone, then we identify the wards. We can use simple random sampling over here again. And then from wards, we identify the slums. So this is what we understand by multi-stage sampling, the key feature being flexibility. But if we look at the advantages, basically, again, even with this method, we get a good representation of the population. And also, it is one of the less time-consuming and less expensive methods. But again, looking at the disadvantages, some people find it quite difficult and complex to take out a multi-stage sampling, to take out a sample through multi-stage sampling. The next type of probability sampling technique is the multi-phase sampling, and this particular technique is taken up when some information is required to be obtained from the entire sample and some information from the subsample of the entire sample. So what is generally done is that collection of the basic information can be taken from the larger sample, and then the more specific information is confined to the successive subsamples. Now here in multi-phase sampling, the sampling unit at each phase, it remains the same structurally. And this again, we need to keep in mind. So let's take an example of multi-phase sampling. For example, if let's assume that we want to screen all the final MBBS students of a particular medical college for tuberculosis. In phase 1, all the final year students can be asked if they are having cough for more than 2 weeks duration. And then all of those who reported having cough for more than 2 weeks duration, that is, asymptomatic students, they can be asked to go in for sputum smear microscopy. So that is what is multi-phase sampling. Now moving on to the other type of sampling, that is a non-probability sampling. Now basically in the non-probability sampling, the key feature over here is that in this type of sampling, the researcher believes in selecting the sample by choice and not by chance. So units in the population, they do not have equal chance or an opportunity of being selected in the sample. Now, what we need to remember over here is that any sampling method where some elements of population have no chance of selection or where the probability of selection cannot be accurately determined, that is non-probability sampling. And here, the selection of elements is based on assumptions regarding the population of interest, which in fact forms the criteria for selection. So because the selection of elements over here is non-random, non-probability sampling does not allow the estimation of sampling errors. So this is one disadvantage of the non-probability methods. The common sampling techniques which we use over here are convenience sampling, purposive sampling, judgmental sampling, quota sampling, etc. And most of these non-probability sampling methods at times are considered as unscientific and less accurate. So they are not very commonly employed as well for research activities. Now let's look at each of these sampling techniques. In the non-probability sampling, we have which the population is segmented into mutually exclusive subgroups, which is similar to stratified sampling. And then judgment is used to select the subjects or units from each of these segments based on a specific proportion till the specified number of sampling units have been achieved. So for example, if a population is there under study consisting of 45% males and 55% females, the sample should reflect these proportions. That is about quota sampling. Advantage of quota sampling is basically that it is easy to manage, it is quick, and the disadvantage, as I have already said about the non-probability sampling methods in general, representativeness cannot be assured, and it is largely dependent on subjective decisions. The next type of sampling which we very commonly use is known as convenience sampling, sometimes also described as grab, opportunity, accidental, or haphazard sampling. And here, this is a type of non-probability sampling which involves a sample being drawn from that part of the population which is easy to get or which is close at hand. In other words, sample which is readily available and convenient. So it is done at the convenience of the researcher. And many times, this type of convenience sampling is taken up for pilot testing prior to going in for the research project. Now, the advantage of this particular method, we've already said, is the ease of access part of it. And again, a good response rate. The disadvantage is that you cannot generalize the findings. There is a problem of reliability, and also whether the respondents are actually representing the target population becomes questionable. So our results are not generalizable. So that is something which we need to keep in mind. The next type of non-probability sampling is the judgmental sampling, also called as the purposive sampling. Now, here the researcher chooses the sample based on who they think would be appropriate first. So, in this is used primarily when there is a limited number of people that have expertise in the area which is being researched. So, the disadvantage is again that we cannot actually measure the representativeness of the population. Now, coming towards the end of this session, we also need to understand what is sampling error. Sampling error, basically it arises because we are taking a sample of the population and not studying the entire population. So it is expected that there is bound to be some kind of a difference between the results obtained if the study was to be done on the entire population as against taking a sample out of it. So for example, if the healthy population hemoglobin level is 14.5 gram percent. In the estimated sample, the hemoglobin levels are coming as 13.5 gram percent. So you have an error of about 1 gram percent between the findings of the study done on a sample as against the population hemoglobin level. So what are the basic factors or the determinants of sampling error? The most important factor is the sample size. If the sample size is inadequate, the chances of sampling error are more. And secondly, the second important factor for sampling error is the natural variability of the individual readings. Now, we know that sampling error, it is unavoidable in a sample study. However, we can minimize it. And this minimization can be done by taking a larger sample. So, larger the sample size, the chances of your sampling error, they automatically get reduced. So, talking about the we know that whenever we are conducting a research, we are generally interested in drawing some conclusion about a population. Now, in order to make inferences about the population, the sample should be representative. And therefore, the manner in which the sample is drawn is extremely important. Understanding the principles of sampling, particularly the limitations and demerits of various methods, it can help us choose the most appropriate sampling technique. And that is the crux of this entire presentation. A few references I have jotted down over here that can be referred to for further reading. Thank you very much.